Okay, we're just going to run through a few more examples here. So I have this rational expression right here. First thing I'm going to do is factor everything. But everything looks like it's either linear. Okay, you can see 2n minus 9 is linear, 7 minus n is linear. Or if it's quadratic, there's only one term. You can't factor one term. We only learned factoring techniques when there were two or more terms. So there's nothing to factor here. Nothing to factor. This is like one of those problems on my first video where there's just nothing to factor, and we got to move on to the second step. What is the second step? Second step is to get rid of the denominators. Two ways to do that, right? We can cancel matching factors, okay? Can I cancel any matching factors here? Sure enough, I can. So you can see there's, in the second rational expression, the second fraction, I have n times n, that's what n squared really is, n times n on top and 2 times n on the bottom. So a times n can cancel, which if I took a times n out of the top, I would just have one n left, which is why I just canceled the 2. And if I cancel that, I've just got a 2 on the bottom. So let me rewrite my rational equation with the factors canceled. Okay. Now, that's a 7. So that was good. I got this denominator smaller, but I still have a lot of denominators, so I have to keep moving. The other way that we learned how to get rid of denominators after we canceled matching factors was to multiply both sides of the equation by the LCD, the least common denominator. What is the least common denominator? Let's remind ourselves. So the least common denominator, it's basically just a number that the purpose of is to get rid of the denominators. Okay, so I'm trying to take one side of the equation and I'm trying to multiply it by something. And if I multiply one side of the equation by something, I've got to multiply the other side of the equation by that same thing. Okay, so what's the smallest thing? That's why we have the word least there. What's the smallest thing that I could multiply by both these equations that would get rid of every denominator? Well, this denominator has a 2 in it. So my least common denominator has to have a 2 in it. And these denominators have an n minus 7 in it. So it's also got to have an n minus 7 in it. So that's a good way of thinking about what the least common denominator is and how you find it. Now if I multiply both of these things through, I'm going to be able to cancel all my denominators. Okay, so let's rewrite this expression here. I've got 2 times n minus 7 times 2n minus 9, okay, over n minus 7. So I've just distributed that least common denominator in my first fraction. Now I've got to distribute it to my second fraction, and I'm going to get 2 times n minus 7 times n over 2, and all that's equal to, now I've got 2 times n minus 7 times 5, 2 times n minus 7 times 5 over n minus 7. Okay. Now, cancel those denominators. That's the whole point of step 2 here. It's the whole point of multiplying by the least common denominator. It's finding something to cancel all the denominators. And what do I have left? All that's left from the first rational equation is 2 times 2n minus 9. The second one is, and I've got n and I've got an n minus 7. I'm going to write it in the reverse order. It doesn't matter which way you multiply numbers, which order. The order doesn't matter, so I can do that. And I'm going to have 2 times 5 is 10. Okay, and step 3 then. Step 3 is to multiply everything together. Okay, do I have stuff to multiply together? I sure do. I've got a 2 times a binomial here, so I'll distribute that 2 into the binomial, get 4n minus 18, plus, and then I've got an n that can distribute into this binomial, n squared minus 7n. It's all equal to 10. Okay, now I'm going to move my way up to here. Do step 4. Okay, step 4 is to get everything to one side of the equation. I want to get everything to one side of the equation. Okay. How am I going to do that? Well, first thing before I even do that, let me combine like terms here. So I just now noticed that I have a 4n here and a negative 7. Oh, you can't even see this. I'm sorry. I've got a 4n here. Just now notice this. And a negative 7n here. I can combine those terms. 4n minus 7n is negative 3n. I'm also just going to order them in the way that you might order a polynomial by putting the n squared term first, and then this combined n term, which comes out to negative 3n here, and then the 18 I'll put last, because it's a constant term. That's the order we usually see polynomials in, is n squared, and then just n, and then the constant term at the end. Okay, so how do I get everything to one side? Well, this side has the least amount of things, so that's the side I'm going to try to get rid of everything by subtracting a 10. But if I subtract a 10 from one side of the equal sign, I've got to do that from the other side. And I'm going to get n squared minus n, or 3n. And then this is going to be minus 28. Minus 28 is equal to 0. Okay, so now, after all that work, I took this really large rational expression and got it down into a polynomial equal to 0. So this is just, I need to solve this polynomial, and this has just become a finding the zeros problem. So I can factor this, right? A times c is 1 times negative 28. I'm doing the AC method here because there's no GCF that can come out, and it's 3 terms. So that's equal to negative 28. And I want to find factored pairs that add up to negative 3. So what's a factored? How does this factor? I can do 1 and negative 28. I can do 2 and what's 2? Negative 14. Okay. I can do, can I do 3? I can't do 3, 4, and negative 7. And actually, I think I just found it because I wanted to add up to my b, which is negative 3. 4 minus 7, if you add them, it's equal to negative 3. And so there's my pair. What do I do with that pair? I'm going to take n squared, and then I'm going to say, instead of minus 3, plus 4n minus 7n minus 28 is equal to 0. I'm going to take the GCF of both sides. First side is n plus 4. GCF of the second side, I've got negative 7 times n plus 4 equals 0. And I've got n minus 7, that's one of my factors. And my other factor is n plus 4 equals 0. So what are my solutions here? Well, my solutions have got to be, if this factor equals 0, then n would have to equal positive 7. And if this factor was equal to 0, I'd have to have n is equal to negative 4. So those are my solutions so far, but I can't stop there. Last video I would have. This video, I've got step 6, which is to check for extraneous solutions. Okay? And in rational equations, what we're really checking for here is the excluded values of the original equation. Okay, so an extraneous solution, even though I got these two solutions because they were solutions to this polynomial, I have to just double check, make sure they're really solutions to what I started with, because that's the whole point here. And the only way they wouldn't be is if they were excluded values. So I've got two different kinds of denominators here. Okay, I've got a denominator that's n minus 7, and I've got a denominator that's 2n. Okay, so what would my excluded values be? My excluded values would be whatever would make this denominator equal to 0, this denominator that appears in two spots, that would be 7. Because if I plug 7 in for n, I get 7 minus 7 is 0. 7 minus 7 is 0. So 7 is an excluded value. And then I've got one more excluded value, which is 0. Because if 2 times n, if that equaled 0, n would have to equal 0. Then I'd get 2 times 0 is 0. That denominator would become 0. So 7 and 0 are my excluded values, which means they cannot be solutions. Okay, so back to step 5. My two solutions were 7 and negative 4. So step 6, checking for extraneous solutions. 7 is an extraneous solution. 7 is extraneous, which means that my answer is n is equal to negative 4 alone. Because 7 doesn't actually work for my original expression, it's excluded from my original expression because it makes the denominators equal to 0, then my only solution now is n is equal to negative 4.